Good morning, guys. Welcome to our YouTube channels. I welcome you all in a Sapience Education. For more details, you can visit our website www.sapienceeducation.com. Okay. So now today I am going to discuss about question number 5.5. So what is question number 5.5? First of all, read it has four parts. So answer the following. Answer the following. The casing of a rocket in a flight burns up due to the friction, at whose expense is the heat energy is required for burning obtained, and the rocket or the atmosphere. So we need to understand what actually they want to ask us. The casing of a rocket in a flight. So casing, did you understand casing? So let us consider there is a rocket, like rocket has some casing. Okay, rocket has outer covering, and this is known as casing. Okay, so what happens? Casing of a rocket burns up due to friction at the expense, whose expense is the heat energy required for burning obtained. Definitely, as we know that due to conservation, as per the conservation of energy, energy can neither be created nor be destroyed. So if one of the thing is burning and it is giving energy, it means that some of the energy has been spent to burn this. Okay, so in casing, rocket burns out. See here, in casing, rocket burn out due to the friction and the heat energy. So as it move up, so there is a air friction, and due to air friction, what happens? Heat is generated, and the casting of the rocket, casting or casing of the rocket comes out of the rocket itself, and the fuel on the rocket burns, which provides the energy to resist the gravitational force and the air resistance. Since when a rocket is moving upward, so it has to overcome gravitational force in downward direction, and when it goes up, so there is a air friction, so it has to overcome air friction. So rocket provides sufficient energy to provide overcome gravitational pull, overcome air resistance, and definitely rocket is responsible, the rocket or the atmosphere. So definitely rocket expenses the heat energy for burning in casing of the rocket against the friction. I hope you have understood. So rocket has to burn its fuel to provide a sufficient energy to burn the casing of the rocket. I hope you all have understood now. Now second part of this question is, comets comets move around the sun is highly elliptical orbit. Comets move around the sun. So suppose there is a sun and the comet is moving around the sun in an elliptical orbit. Suppose this is your comet, and the gravitational force on the comet due to the sun is not normal to the comet's velocity in general, yet the work done by the gravitational force over every complete orbit comets is zero. According to this, when comet is moving in elliptical, so it means that the velocity of comet and the gravitational force is not perpendicular, not 90 degree, and we know that work done is equal to force due to gravity or gravity pulled by the sun, and to comet's displacement. Okay, displacement, and into cos 90 degree. So as per it, if 90, the displacement, and see here, comet's displacement and the force due to gravity is not 90 degree, so it means that work done cannot be zero, but instead the work done in the gravitational force for every one complete orbit in a comet is zero. So in spite of this, when a comet complete one complete orbit, so what happens? Work done is zero. Why this? Work done can only be the work done can only be the case where the cos 90 is zero, that is direction of force due to gravity and the displacement should be 90 degree, but in the case of comet both are not at a 90 degree. Then why the total total work done by the comet will be 0. Total work done by the gravitational force over one complete. Total work done by gravitational force on a comet should be 0. Why? But as per the definition, there is it can't be 0 because displacement and the force due to gravity and displacement is not 90 degree. So what we need to do? So as you know that it gravitational force gravitational force is conservative force conservative force conservative force, and work done by conservative force work done by conservative force in one complete orbit is 0, as it does not depend on path followed, as it does not depends upon path followed depends upon path followed. I hope you all have understood now, right? So that's why work done is 0. Work done by conservative force is equal to 0 in one complete revolution. Okay, now let us go for next section. Next, see what is the question. Now see, an artificial satellite orbiting the earth in a thin atmosphere loses its energy gradually due to the dissipation against the atmospheric resistance, however small. Why then does its speed increase progressively as it comes closer and closer to the earth? So question you need to understand, this is your earth and there is a satellite. As satellite is coming toward earth, what happens? As satellite is coming toward earth, then what happens? Kinetic energy is increasing. But as per the question, if it is moving toward earth, so it has to overcome air friction. So as it is coming toward the earth, so it has to overcome friction. It means velocity will decrease, or we can say kinetic energy will decrease. But in spite of this kinetic energy is increasing. Why so? As we know that total energy is equal to potential energy plus kinetic energy. As you know that when a satellite is coming down, so it means that potential energy is decreasing. So if potential energy is decreasing, so what will happen? As we know that as per conservation of energy, total energy should be remain constant. Conservation of energy, total energy should be remain constant. It means that if total energy is constant, it means that potential energy, if decreases, then kinetic energy will increase. Only some amount of potential energy's expense goes to overcome the air friction. Okay, for example, an object is coming down, so little amount of energy has been expend in overcoming the air friction, but most of the potential energy gets converted into kinetic energy. The main reason is that when satellite is coming down, potential energy is coming down, but as the conservation of energy, total energy should remain constant, but here potential energy is decreasing. It means that kinetic energy has to come increase. So if kinetic energy is increasing, is increasing, it means what? Which replies that velocity will increase. Velocity will increase, right? So I hope you have understood this question. So I hope this is clear. Question number 5 point, question number 5.5c. I hope you all have understood. Now it is a turn of question number 5.5d. So let us discuss about 5.5d, what they want to say. Okay. A man walked 2 meter carrying a mass of 15 kg on in hand in figure 5.132. So this is what they are talking. He walks, see here, in figure 1 the man walks 2 meter carrying mass of 15 kg on his hand. So a man is carrying mass, so man is applying a force to lift the object in upward direction. So man is applying a force in upward direction. I am discussing about case 1, right? So man is applying a force of upward direction to take this body in up, but the man is going in forward direction. So can you tell me now theta is what? 90 degree. Angle between applied force and displacement is 90 degree. It means that work done in this case is equal to force into displacement into cos 90, and this will be 0. So case 1 work done is 0. Now second case, he walks the same distance, so displacement is same, and the rope behind him, and the rope goes over a pulley, and mass is 15 kg hang on its other hand. So in which case the work done is greater? So case 2, work done in case 2, we will talk about work done in case 2. So how to find work done in case 2? Now let us consider. See here, man is applying a force in this direction, and at the same time man is getting displaced by 2 meter. So now what is the force? What is force? So force applied by the man is equal to tension in the string, and tension in the string is what? See here, force applied, try to understand. See this rope, force applied by the person is tension, is equal to tension, and what is here tension? Tension is equal to mg, that is force due to gravity. So it means that man applies how much force? Man applies a force equal to mg, and this is equal to mass is 15 into g is your 9.8. So this will be how much? This will be 15 into 9.8. So this will be 147 Newton. Now what will be the work done? So work done in case 2 will be equal to force into displacement into cos 0 degree. Why 0 degree? Because see here, applied force by the man is in the same direction as there is a displacement. So cos 0, that will be 1. So this is your 147 into displacement is 2. So displacement is 2. So we are getting 294 joule. Hence work done in second case is more. Work done in case 2 is more. I hope you have understood now. Okay, I hope you all have understood now the all parts. Thank you everyone.